Chapter 4.3 is on second-order determinants. A second-order determinant is a square array of numbers that is expanded according to this rule. So if you have your square array of RSTU inside what looks like absolute value bars, but that's what signals as a determinant, then it'll equal RU minus ST. And so what you do is you cross multiply. So it's R times U and S times T to get RU, and then it's a negative, so minus ST. And that's second order determinants, and we can use those to solve systems of equations. So if we're given the two equations of AX plus BY equals C and DX plus EY equals F, in all the A, B, C, D, and F stand for constants. So if we were going to solve this like as a system of equations, we'd multiply the first equation by E and the second equation by B. And that would give us AEX plus BEY equals CE. And on the bottom, BDX plus BEY equals BF. In order to eliminate the y, we would subtract this bottom one. So we would get X AE minus BD equals CE minus BF. And then you can see that then the X can be written as CE minus BF over AE minus BD, where you would just divide by what X is multiplied by, and then similarly Y, if we'd solve for Y instead of X, would equal AF minus CD over AE minus BD. And if we're looking at these, you can observe a couple things that they have in common. So a couple observations are that for both X and Y, the denominators are the same, but the denominators only contain coefficients from the left side of the equation, from the side of the equation that has the X's and the Y's. Also, the numerator for X does not contain any of the X coefficients, and the numerator for the Y does not contain any of the Y coefficients. So the X numerator does not contain an A, and the Y numerator does not contain a E or B. And so then we can use determinants to find the values of X and Y. And so first we're going to start off with finding the denominator. So you can find the denominator using the second order determinant. So if we remember the general equation of AX plus BY equals C and DX plus EY equals F, we use A and B, which are A, B, and then D, E. So the denominator is just the left side. And then we can simplify it along the same way, which is the cross multiplication. So that equals AE and then subtraction BD, which, if you remember from the previous slide, is the denominator for both the X and Y. And so we can use determinants to find NX, which is the X numerator. And we do that based on the denominator matrix, which is the second order determinant, by replacing the X coefficients with the coefficients from the right side of the equation, the constant side. So NX, we would draw our matrix, and instead of putting A and D on the left side, we would put C and F, and then B and E, which are the Y coordinates. And then to cross multiply, you go CE minus BF, which then gives us X of CE minus BF over AE minus BD, which is what the addition and subtraction method would have given us as well. And similarly, we can find ny by replacing the y coefficients with the coefficients from the right side. So for ny, we'd go back to the denominator matrix, but replace the y coefficients, so the ones on the right-hand side, with the coefficients from the real right-hand side. So we would have a, d, and then the coefficients on the right-hand side, so c, f, which would then simplify to a, f minus c, d. And so the solutions to second-order determinants are called Cramers Rule. And Cramers Rule states that x and y can be found by doing nx over d, and y is ny over d. So now we're going to use Cramers Rule to simplify this set of equations. So 3x plus 4y equals 2, and 5x minus 7y equals 17. So if you remember, x equals nx over d. So x we equal, so we're going to do the denominator first because it's the easiest, so 3, 5, 4, negative 7. And you just write the coefficients for x and y. And for the numerator, we change out the x coordinates, so 3 and 5, with the ones from the right hand side. So 2, 17, and then you keep the y ones. So 4, negative 7. And that will simplify to, with cross multiplication, negative 14 minus 68 over negative 21 minus 20, which simplifies further to negative 82 over negative 41, and that equals 2. So x equals 2. For y, you know that y equals ny over d. So y will equal, we already know from solving for x that d equals negative 41. So you don't have to redo that. But for the y one, remember you do the y matrix, you do the x coordinates 3, 5, and the ones from the right hand side of the equation, so 2, 17. Simplifies to 51 minus 10 over negative 41. So 41 over negative 41 equals negative 1. So then our answer in x, y is 2, negative 1. And that's another way to solve systems of equations.